Odds are, if you're a developer who's been working on your game for a while, you've asked for some feedback, and you've struggled a little bit with the feedback. Perhaps not in receiving it, but figuring out how to interpret it. Are you getting accurate information? Is it really describing how they feel? Are they telling you the truth? Well, what if somebody invited you to get directly into their head and to see what they're seeing or feel how they're feeling? Welcome to the world of biofeedback, and our next speaker is here to talk a bit about that. Though she currently works as a game designer on League of Legends at Riot Games, she's bringing her experience as a computational and neuroscientist to the table. She's spent years working in medicine, even to the extent of helping design a tool that allows people to control a game with just a thought. Please welcome to the stage Noor Amin.
Hey everyone, I'm Noor, she, her, and I'm going to talk to you all about mind and machine, exploring biofeedback in game design. To share a bit about my story, I'm a relatively new member of the games industry, and prior to my current role at Riot Games, I was a fairly uncommitted pre-med student majoring in computational neuroscience. I started working in medicine in 2020, which is definitely a year to start working in medicine, after helping out with a handful of lighthearted subjects like COVID and cancer. I found my niche working in motor disability research, designing gesture-based controllers for folks who wouldn't otherwise be able to interface with technology. And after a very straightforward career in medicine, I took the next logical step after graduation, which of course for any pre-med student is working on League of Legends. And I've been here for 1 year as of this week. But today I'm not going to be wearing the designer hat, and instead I'll be chatting about a design topic that largely originates from neuroscience. That topic is called biofeedback. Biofeedback is formally defined as the process of gaining greater awareness of many physiological functions, primarily using instruments that provide information on the activity of those same systems. That definition is really confusing. Welcome to neuroscience, everyone. So I'll take a stab at it. As designers, we do a whole lot of thinking about how our games create experiences for our players. We do a lot less thinking about how our players impact our games. That happens for a variety of reasons, but one of them is that we tend to think about players as a homogeneous group. On League of Legends, we have some course methods for segmenting players, like region and key preference. But those parameters are not nearly specific enough to capture the diversity of our fans. In actuality, each player is made up of unique cognitive and perceptual systems that filter the experiences we create. And understanding those systems can open up newer, deeper, and more emotional avenues of engagement with the games that we love. This is where biofeedback lives. Put simply, biofeedback is a feature that uses special devices to make stuff responsive to the user's body. And to me, biofeedback has three main use cases: biofeedback as a mechanic, as an input scheme, and as a playtesting tool. First, looking at biofeedback as a mechanic, the game I'll reference is called Nevermind, which is a first-person horror game developed by the indie studio Flying Mollusk. Nevermind is split into a series of rooms with puzzles that the player has to solve in order to escape. The biofeedback feature emerges through the game's recording of the player's facial expression and pulse to determine what they're feeling and how intense that feeling is. The difficulty of the puzzles in each room scales based on the player's emotion. In this example, the player is stuck in a room that's flooding, and if the player is really scared, the room will flood faster. So they have to intentionally stay calm in order to escape. Another example is the scene where the player has to sort through puzzle pieces in a dimly lit room, and the light intensity changes based on the player's pulse. I often reference Nevermind not because I think it's particularly representative of all biofeedback games out there, but because it's a really good starting point for a more speculative discussion about what these types of games could be. Emotion is just one of the many, many, many things we can measure from a player's body, which ranges from attention to social engagement to perceptions of novelty. And this is not something I have any specific expertise on as a neuroscientist, so I'll pose it as a question for you all. When we can measure a player's internal states, what types of gameplay can we create? Think about enemy design. Imagine you're designing a roguelike, and you could determine what type of challenge the player is craving at a given moment and spawn an enemy that meets those specifications. For those of you in behavioral systems, think about adaptive profiling. Imagine if you could determine that a player will say something harmful over voice or chat and issue a preventative measure before it ever impacts another player. For those of you into RPGs, imagine what role-playing would look like if companions could respond to your facial expression and body language just like real people sometimes can. Even better, what if we give companions access to your raw emotional data? They could understand your feelings better than real people can. The takeaway of that thought exercise is that with biofeedback, gameplay is no longer one size fits all. It's adaptive on a per person basis. But maybe we don't need that right now. From an outsider's perspective, I think designers are extremely perceptive by nature, and maybe all of the supplementary data sounds extraneous to you. So let's look at an example of biofeedback that's integral to the experience. Transitioning into input schemes, I'll start with this video of myself because I'm really vain. In this video, I'm using a biofeedback device called an EEG, which stands for electroencephalogram, to read electrical activity from my brain and use it to control a character in 2D space using just my thoughts. What's really exciting to me isn't that this is a good control scheme on its own, because I don't think that. It's thinking about this in the context of accessibility. I want to give a content warning for the next couple of slides, where I'll be discussing surgery and depicting body modification and needles, but no blood will be shown. If that's not your thing, please feel free to skip ahead to the next section. So thinking about accessible input schemes, I'll share a little bit about research that I was involved with. This subject, Scott, was injured in a car accident in the 1980s, which eliminated his sense of touch and left him paralyzed from the neck down. He has sets of electrodes like the one showed here, implanted into the brain regions responsible for movement and touch. And even though he can't move his real body very well, he can still think about moving, and we can use those thoughts to control a virtual limb in a really simple VR game.
Scott is performing a couple of different types of tasks. One type of task is what we call a motor task. So this is him thinking about moving his own arm and hand, and instead moving this virtual robotic arm and hand that we have for him. And he can do a variety of different tasks. So different, reaching and positioning the hand in space, grasping and moving objects, and even also grasping objects with varying amounts of force. These are some of the tasks that he does regularly.
I can't show complete footage of internal research, but these are basically sorting games where he manipulates 3D objects in space. From those movements, he also receives haptic feedback, meaning that when he touches a plushie in VR, we send an electrical current to his brain, which simulates a touch sensation that feels soft, as if the plushie were in his real hand. Effectively, Scott doesn't have touch or motor control in the real world, but we can make biofeedback games that restore those functions. And this is beyond the scope of the presentation, but the reason we create those game sessions is that we write decoders for real bionic limbs that are also sensorized.
How you doing, Scott? Nice to meet you.
Nice to meet you, Scott.
With volunteers including Scott Embry,
And you can feel that.
I feel it on my fingertips.
whose movement and sense.
Scott's pretty proud of that one. So biofeedback makes a lot of big promises of fixing everything we hate about input schemes, even beyond the context of games. They're fully customizable, there's no learning curve, dare I say universally accessible. So what's wrong? Why haven't we invested further into this tech? The answer, much like everything else in life, is money. If you're into non-invasive devices, which is what I use on myself, you're looking at anywhere between 1 to 30 grand a pop. And if you want Scott's device, which is a fully sensorized, brain-controlled bionic limb, you're looking at least 7 figures. The key takeaway here is that biofeedback drives incredible accessibility outcomes, which is a massively underinvested area in games. At the moment, it comes with a big price tag, but to share a little bit of insider knowledge, this is something we expect to be commercialized in the next couple decades. And when it is, it'll fundamentally change the way the average gamer thinks about controllers and inputs. But while we're waiting for the neuroscientists to cook, let's take a different case of biofeedback that's a lot more practical and grounded. Playtesting tools. And I'm going to tell a story about a game we all know. Many moons ago, Fortnite was coming out with their harvesting system, where destructible objects had weak points that sped up harvesting, highlighted by this circular icon. And when they playtested, developers were seeing this behavior. Players were harvesting, but they weren't hitting the weak point. So the UX director at the time, Celia Hoden, asked players why they weren't targeting the weak point. Were they not paying attention? Was it because they weren't motivated to optimize their harvesting? Did they not get what the icon meant? And she got a whole lot of this answer. And I think that's a problem we can all relate to. Sometimes players just forget. Sometimes they try to solve your problem without telling you what the problem is. Sometimes they make stuff up. Basically, playtesting is really hard, and a lot of feedback we get from traditional tools like direct observation, surveys, in-game metrics, or my personal source of truth, reddit.com, isn't as actionable or as valuable as it could be. So getting back to Fortnite, what the UX director did was that she playtested again with a much smaller group, but this time she used eye tracking and found that players weren't looking at the icon at all. The issue was really simple. The icon wasn't as salient as other eye-catching VFX and UI in the same view. So they changed the icon and players accordingly changed their behavior. Notably, eye tracking isn't the only right approach. Even without knowing exactly what the problem was, you can imagine that the weak point system could have been tutorialized and gotten the same behavioral results. But that's a lot more development costs wasted on a problem that could be solved by swapping out an icon. The takeaway of that story is that traditional playtesting tools tell us what players are doing, but they don't always provide insight into why they're doing those things or how they're experiencing them. That type of feedback is really challenging for players to articulate, especially in real time. Biofeedback can close a lot of those gaps. It allows us to ask a question at every moment of a playthrough, and we get an answer without interfering with the experience. And we're no longer limited to the types of data we can see, ask about, or infer through proxies. For example, we can predict whether a player is about to quit a session or churn forever. We can understand first impressions of new content, or how helpful a tutorial is, or whether the player is learning. My manager often talks about being goal-oriented in our design approach, but at the same time, we don't always have objective and reliable means of evaluating whether our designs are executing on their sensational goals once they're out there in the hands of players. And the hypothesis I want to put forward is that we can make more informed decisions about improving the player experience if we had access to their internal states and emotions. In sum, biofeedback could do a whole lot for designers, from new mechanics to accessible controls to more informative playtests. But most importantly, it helps us to be speculative about what the future of gaming looks like. It's hugely convenient that the electricity that runs through your body and the electricity that runs the video games we play are fundamentally the same thing. And I encourage designers to think about what happens when we connect the two. And that's all I got. Thank you.
Thank you so much for that talk, Noor. I gotta admit, I feel like I might give a little too much feedback that way. I might want to keep some of that to myself, but I do genuinely appreciate this idea of finding ways to use technology to make better, more meaningful connections with our players and with folks in general. I also really loved seeing the ways that some of this technology brings accessibility to the game space and helps people access games in ways they couldn't before. So thank you for sharing those stories, Noor. Now, we are heading into our second break, and I do have a question. Have you checked out SwapCard? Have you taken a look at any of the booths that have been set up by our exhibitors, by our sponsors? Have you made some connections, scheduled some appointments to maybe do some networking, meet some new people? This is a really great opportunity to spend time with folks who care about and experience some of the same things that you do. So take advantage of the time. Go explore. And we'll see you when we get back, because we do have yet another Sharpie Dev interview. This time exploring a kind of scary 90s themed look at the internet. Though I will say that I do think that this interview has one of the most calming voices of GDOC 2024. And I get that that's me saying that. I have a bit of a reputation. But trust me on this. You'll really enjoy it. We'll see you when we get back.